Hi, previously I designed the PI controller to improve the step response of a first-order RC circuit. The algorithm was then implemented on a DSPIC microcontroller and resulted in a closed-loop response that satisfies the desired specifications. But this only holds if the sampling rate is fast enough. So if I were to reduce it too much, the overshoot would grow larger than intended. Rather than retuning the gains until the specs are met again, I chose this time to design a digital controller entirely in the Z domain. The first step in this process is to convert the continuous transfer function cascaded with a zero-order hold to its discrete equivalent. A sampling period of 100 milliseconds has been chosen. The next step is to find the second-order closed-loop transfer function that satisfies the same specifications set in the previous video. No steady-state error, a settling time of 2 seconds, and an overshoot that does not exceed 20%. The latter two can be linked to the damping ratio and the natural frequency, then to the required pole positions in the S domain, which in turn are mapped into the Z plane. As these are the roots of the characteristic equation, the denominator of the closed-loop transfer function can now be deduced. Based on the final value theorem, zero steady-state error to a step input is achieved when the closed-loop transfer function is equal to 1 for z equals 1. The numerator polynomial can now be deduced. The final step is to find the expression of the controller, which can be obtained from the formula of the closed-loop transfer function. By cross-multiplying, simplifying, and then taking the inverse Z transform, we get the expression of the numerical algorithm. As the output of the controller relies only on past values of both of the output and the error, it can be implemented on a microcontroller. By applying a 1-volt step input, the closed-loop system reaches the desired set point in 2 seconds, and does not overshoot more than 20%. And contrary to what was shown at the beginning, the result is exactly what was predicted by the equations, without any further tuning needed. I hope that you enjoyed this demonstration, and I thank you for your attention.